Okay. So last time we introduced the properties of the gases. So this chapter we will learn the properties about the liquids and the solids. So in this chapter we will introduce the intermolecular forces and also properties of liquids, and of course the very simple, very common properties of liquids and other solids. And we also will introduce the phase changes. So phase change is we know for all mass they have three phases, right? So what phases they have? What three phases they have? Gas, liquid, and solid, right? So phase changes means the elements or the compounds can change from like gas to liquid or liquid to gas, something like this. Okay. So a phase is a homogeneous part of the system in contact with other parts of the system, but separated from them by a well-defined boundary. So, for example, in this picture, for the water, how many phases? Yeah, two phases, right? Right, solid phases is ice, okay, and the liquid phases is water.
But again, when there is ice also produces some vapor sometimes.
Of course, yes, there will vapor, but yeah, of course. You can also suggest three phases in this picture. Now, what maybe we can say that, right? What we can say in these phases, there are definitely two phases, and so and also between the phases, they have where they have a boundary, right? Their boundary. Okay, so this is about phase. We know basically the matter has three states. So like a gas, liquid, and a solid. And this table to show some simple properties of the states. For example, gas, of course, we know the density is very low, and liquid and solid they are higher than gas. Okay, so this is about phase. So here we introduce the intermolecular force. So basically, when we discuss the forces, usually they have two kinds of forces. One is called intermolecular forces. Another one is intramolecular forces. And intermolecular forces are attractive forces between the molecules. Okay, between the molecules, like an oxygen gas. Okay, between the oxygen O2, they have some interaction. So this kind of interaction or forces are called intermolecular forces. And of course, in one molecule, there are also some forces. So these forces are called intramolecular forces. Okay. So intramolecular forces hold atoms together in a molecule. For example, O2, oxygen gas. So O2 and between the two oxygen atoms, there are some forces hold them together, right? So what are the forces? It's bond. Okay. Between the in one molecule, the intramolecular forces mean the bonds, the formation of the bonds. Okay. So basically, the bonds is very stable. is very stable. So the intramolecular forces are larger or are bigger than or stronger than intermolecular forces. Okay. So for example, here we show the energy of these two kinds of forces. If we vaporize 1 mole of water, we need to provide 41 kilojoule energy. Okay. So this is about the intermolecular forces. We vaporize 1 mole water from liquid water to gas. It means we need to break the forces between the molecules, right? Yeah. So it is about the intermolecular forces. So the energy is 41. But if we break all OH bonds in 1 mole of water, we need to provide 930 kilojoules. So we can say this is about 20 times of this guy, right? Of this number. So this means the intermolecular forces are much stronger than intermolecular forces. Okay, because the molecule is stable, so you need to provide more energy to break the bonds. So the intermolecular forces are much stronger than intermolecular forces. Okay. So basically, like we can match the intermolecular forces. It's like they are boiling point or melting point. Okay. For example, the boiling point, it means the matter changed from liquid, boiling point liquid to gas, right? So if the boiling point is high, what does this mean? If it's high, the intermolecular forces are strong or weak. If the boiling point is high,
very strong.
yeah, very strong. So this means the intermolecular forces are strong. Okay. So we can also use the energy, like evaporation, fusion, sublimation energy to show the intermolecular forces. Okay, and we will introduce this energy later. Okay. Okay, so this is about intermolecular forces and intramolecular forces. Okay. Okay, so now we know that intramolecular forces is bond, right? We introduced the bonds in the last 2 chapters. Here we introduce the intermolecular forces. Okay. So basically there are 4 kinds of intermolecular forces. The first one is called dipole-dipole forces. Second one is ion-dipole forces. The third one is dispersion forces. And the fourth is the hydrogen bond. So, for example, for hydrogen bond, you should learn about the hydrogen bond in your high school, right? Hydrogen bond. Okay, yeah, we will introduce also this. So hydrogen bond, of course, is one kind of intermolecular forces. So first one is dipole-dipole forces. So what is dipole-dipole forces? So dipole-dipole forces, it means the active forces between polar molecules. With the molecules, we introduce the molecules. Some molecules, they are polar molecules, right? But for some molecules, they are no polar, right? For example, CH4 is polar or not? Is polar? No, yeah, it's no polar. Because you know the geometry of the molecule is tetrahedral, right? So So if the molecules are polar molecules, so they will form the dipole-dipole forces. Dipole forces mean like this. We know for polar molecules, for example, carbon oxide. So in this molecule, the carbon has some positive charge, right? And oxygen has some negative charge. So like what is this is the carbon side, this is oxygen. So between the oxygen and the carbon, they will form the intermolecular forces. Okay, because they have the different charges. So we know different charges particles will attract each other, right? So this is the first kind of intermolecular forces, dipole-dipole forces, dipole-dipole forces. So for all polar molecules, they have dipole-dipole forces between because they have different charges, and the parts with different charges they can attract each other. So this is the first one, dipole-dipole forces. So any question for this? Okay, for example, I have a question. So between the O2, oxygen, between the oxygen molecules, are there any dipole-dipole forces between the oxygen molecules? O2 molecules? Yes or no? Oxygen, between the oxygen molecules, are there any dipole-dipole forces? No. Yeah, because oxygen are no polar molecule. Okay. Just when the molecules are polar, so they will form the dipole-dipole forces. Second one is called iron dipole forces. So iron dipole forces, it means attractive forces between an iron and a polar molecule. So the iron can be an iron, right, or cation, right? For the metal iron, it has positive charge. For an iron, like a fluorine iron, so it has negative charge. So between an iron and the polar molecules, they will form iron dipole forces. For example, you can see also this is the carbon oxide, okay? Carbon oxide. So when the sodium cation close to the carbon oxide, so they will form between the sodium and this oxygen, right? Oxygen has negative charge. So plus charge, negative charge, so they will attract each other. And if this is an iron, so this side is carbon. Okay, so between the iron and the carbon, they will form the iron dipole forces. So this is the second one. So between the iron and the polar molecule, they will form iron dipole forces. Okay. So any question for this? For example, when the sodium dissolved in water with the salts, right? The salts NaCl, sodium chloride. When the sodium chloride dissolved in water, the formation will be like this. For example, this is sodium, okay, and some water molecules will surround the sodium, and this is water, oxygen. The red one is oxygen, and hydrogen. So the oxygen will tend close to the sodium to form the iron dipole forces. So the structure will be like this. The oxygen will we'll try to close the sodium. Okay. So this is about the second one, iron dipole forces. Third one is called dispersion forces. So dispersion forces means attractive forces that arise as a result of temporary dipoles induced in atoms or molecules. So what does this mean? This means, for example, I2 iron, this molecule is polar or not. So basically it's no polar, right? But when a cation like sodium close to this molecule, so the shape of the I2 will change like this. And this part has some negative charge. This part has some positive charge. So between the sodium and this part, there will form intermolecular forces. Okay. So this forces is called dispersion forces. So, and this dipole is called temporary dipole. Why it has temporary dipole? Because the size of the molecule is large. It's large, so it's cheap or easy to be changed. Okay, easy to be changed. So, and the way it's changed, so it's possible one part has some negative charge, one part has some positive charge. Okay, so when the sodium close to this guy, so they will form the intermolecular forces. So this is called dispersion forces. This is one kind of dispersion forces, and it's called iron-induced dipole interaction. Iron-induced, because the temporary dipoles is induced by time. Okay. The second one is called dipole-induced dipole interaction. So what does this mean? So in this case, this is the temperature of the dipole is induced by cation. In this case, the temporary dipole is induced by dipole molecule. Okay. So besides the cation or an iron can induce the temporary dipole, the dipole molecule also can induce the temporary dipole of I2. For example, this carbon oxide. So carbon has some plus charge. So the shape of the I2 will change like this. So in this part, some negative charge. So in this part, some positive charge. So negative charge will attract by carbon, and this positive charge will attract by the oxygen. So between the dipole molecule and the neutral molecule, okay, or between the dipole molecule or no polar molecule, they all still can form intermolecular forces. So this is about this kind of force is called dispersion. Dispersion means dispersion. In dispersion forces, they are temporary dipoles. This is the first two types. And the third one, the temporary dipoles of molecule can not only could not only be induced by ions or dipole molecules. It also can induced by each other, by themselves. Okay. For example, the iron. So in fact, because the shape is large and the shape is easy to change, so it will form like this. I mean, they will stay like this. Okay. So there are some positive charge and this selective charge close. Okay. And this positive charge will close to selective charge. So in fact, for other molecular gas, they will form like this. Their formation is like this. Okay. This is temporary dipoles induced by themselves. Okay. So here we introduced there are three kinds of dispersion forces. Okay. The first one is called ion induced. The ion can be cation or can be an ion. Okay. Second one is dipole induced. So it's induced by the dipole molecule. The third one is just induced by themselves. Okay. So basically, this means for dispersion forces, these forces can exist in all gases. Okay, in all gases. And how to judge the dispersion forces? So basically, using the polarizing ability to judge this force. So the polarizability is the ease with which the electron distribution in the atom or a molecule can be distorted. So basically, if the molecule has more number of electrons, it has more electrons. Like the period, right, is the first period, the second period, the third period. Okay. Of course, the third period and the fourth period have more electrons, right? For these kinds of atoms, they have higher polarization. They have higher polarizability. Okay, and also more diffusion electron cloud. It also means like if the molecule has more electron and it has higher size, it has big size. So basically, they have higher polarizability. Okay. So we know this force is usually increased with the molar mass. Because when the molecule has a large molar mass, it means it has more electron and it has large size. Okay, so this force is also very important to some physical properties of matter, of compounds. For example, in this case, we can say the melting point. This is all this is carbon, right? This side is carbon, and this side, this is one group, right? So from up to down, the size of the molecule increase or decrease? Increase, right? This, of course, iodine is larger than bromine, right? Is chloride. And also, this guy also, and from up to down, they are electrons number increase or decrease? Also increase, right? So this means they are from up to down, they are polarizability increase or decrease? Increase. So when it's increase, so the dispersion forces between the molecules from up to down increase or decrease?
What's the question?
The dispersion force,
Increase.
yeah, increase. Increase. If the dispersion forces from up to down increase, so this means the attractive forces between the molecules increase or decrease? Decrease.
Increase.
Increase. Okay, increase, so this means their melting point will also increase. Because the force stronger, right? It becomes stronger. So you need to provide more energy to break the intermolecular forces. It also means the dispersion forces. You need to provide more energy to break the dispersion forces. So there are melting point increase. This is why from like here hydrogen, chlorine, bromine added, there are melting point increase because for this it has much higher dispersion forces. Okay. So as we know the intermolecular forces, we can understand there are some properties. Okay. Question. So what types of intermolecular forces exist between each of the following molecules? So basically here we listed three kinds of intermolecular forces: dipole forces, ion dipole forces, dispersion forces. So basically there are three kinds of intermolecular forces. And we also just now introduced what is forces. So HBr, CH4, SO2. So for these compounds, so what type of molecular forces? Anyone have a try? Yeah, okay. Okay, yeah, you can. Yeah.
H4 will be dispersion force.
So the first one,
I know the second one.
you know the second one.
Yeah.
Okay, second one, what kind of forces?
Dispersion force.
Yeah, dispersion forces. Okay, and no dipole forces, right? And also, yeah. First one.
Yeah.
First one. Dipole forces? Yes or no?
Yes.
Why?
Hydrogen, bromine, and hydrogen.
Yeah. Because HBr is polar. It's polar molecule, right? It's polar molecule means hydrogen has some positive charge, bromine has some negative charge. So it's dipole forces. And only dipole forces was the first one. Was the first one only dipole forces? Yeah, dispersion. Okay. Because it also can change the shape of the BR can also change. Okay.
Yes.
The third one.
Last one. Dispersion.
So you know what's the SO2, the geometry?
You see, you separate
It's bent. Okay, so it's polar, right? So it's polar, so polar movement, so what kind of forces? Yeah, type forces and dispersion. Okay. You know, for all basically for all gases, molecules, so they have dispersion forces. Okay. Just some has higher dispersion forces, some have weak dispersion forces. Okay. This is no polar, so it only has the dispersion forces. So this batch, right? So it has type forces. So basically, you need to know firstly, the thing out is geometry, and we introduce the geometry, how to determine the geometry of molecules, right? And then if it's polar molecule, so it has type forces. Okay. And all these gases have dispersion forces. Okay. Now we introduce the first one, hydrogen bond. So what's hydrogen bond? Hydrogen bond means it's a special type of interaction between the hydrogen atom in polar NH, OH, or FH bond and electronegative oxygen, nitrogen, or fluoride atom. So for example, between the water molecules, oxygen, hydrogen, they will form hydrogen bond. Okay. NH hydrogen bond, FH hydrogen bond. So this is called hydrogen bond. Okay. So basically, the hydrogen bond only means the forces formed from the nitrogen, oxygen, and the fluorine. And because it's also a special type of interaction. But this very stable because this forces is basically is stronger. It's much stronger than other intermolecular forces. Okay, so we just call them hydrogen bond. Hydrogen bond. You know, for this, because this, why we call them hydrogen? Because these three atoms has much higher electronegativity than other atoms. So we call the forces between nitrogen, oxygen, fluorine, and hydrogen. We call them hydrogen bond. Hydrogen bond. Okay. Okay. So the hydrogen bond also we can say has a key role in some properties. For example, this is the boiling point of the compounds of these four groups compounds. So this is in one group, okay? Oxygen, sulfur, Se. This is one group. It's group 6. This is group 7, group 5, group 4, and this is boiling point. So from here we can see, if we don't see these three, we know that this is oxygen, fluorine, nitrogen. If we don't see three, we can see this carbon. In one group, from this side to side will increase, right? They are boiling point. Like from carbon, from in one group from this guy to the guy increase. Why? See this group. Why from this guy to this guy to this guy, their boiling point increase. Right. In this group, why the boiling point has this tend increase? We just introduced. Why?
Because more numbers.
Yeah, because more molecules, more electrons, right? And the size is larger, right? But the reason is the forces. What kind of forces? Which one? Remember? Dispersion. Yes. Because from here to here, they have more. This guy have more electrons and has as is larger, so it has higher dispersion forces. So the dispersion forces of this guy is higher than this guy, is higher than this guy, is higher than this guy. So their boiling point increase, right? For example, do you remember? Right? From carbon, from this guy to this guy, their boiling point, their melting point increase, right? So melting point or boiling point have similar means. So melting point means from solid to liquid, right? Boiling point from liquid to gas. And of course, in the solid state, if the intermolecular forces is stronger, of course, they have high melting point. And also, they will have high boiling point. So when the dispersion forces increase, there are melting point increase. So in this case, we also can say with the increase of the dispersion forces, there are melting point, their boiling point also increase. Okay. So here we can say increase, right? But for these three guys, they have much higher boiling point than this guy. So we can say the tens of these three are different from this one, right? Are different from this one. So now the question is, why these three compounds have much higher boiling point than this guy? So basically, for example, they are small, right? They are small and they have few electrons. So the dispersion forces between the molecules should be small, should be weaker than this guy, right? But in fact, they still have high boiling point. Why? This trend is decided by dispersion forces. But here, they have higher boiling point than this one. Why? What? So they have a high boiling point. It means their intermolecular forces are higher, are stronger, right? Why? Why they have stronger?
Therefore, the group was
Dispersion? Double? What's this? Hydrogen bomb. Okay. Because they have very, you can also say it's a double interactions. But because they have strong hydrogen bond between the molecules, so they show higher boiling point because the hydrogen bond is much stronger than the dispersion forces. Okay, so they still have higher boiling point. Okay, have a short break.